Now we are going to see all the 4 configurations and try to authenticate using the ACR122U and the PCSC commands, and later on we are going to see with the PN532 command as well. So here I'm using the ACR122 Made Easy software version 1.3. We have seen this software in one of my earlier videos on this MIFARE Classic 7-byte UID. So choose MIFARE Classic 1. So I'm going to authenticate the UID of 0. So this is 7-byte UID, and when you activate, and you can see that this UID, the get data command of this one ACR122U, returns the 7-byte UID. And when you try to authenticate, I'm going to authenticate and read the content of sector 1. So authenticate. So authentication is successful, and if you look at the commands, we have used the PCSC commands for MIFARE Classic, where the first command is to load the keys into the reader, and the second command is to tell the reader to authenticate. So these 2 commands are very well documented in the ACR122 document, and I would advise you to now read from there. Now we are able to authenticate. I'm going to read the sector, and the most important thing to notice here is the UID, which is the 7-byte UID, is stored in the block 0 of this tag and starts from the byte 0 and goes up to 80. So these 7 bytes are the UID, and this is followed by something else. Probably this could be the BCC of all. If you take a XOR of all these things, you should get this, and this and this, this is the A2QA, and this I'm not very sure, and I know that B11 is the value, the settings of the modulation, whether it's a strong or a weak modulation. Probably now later in the videos I'm going to show you what this how to set this modulation type. So the most important thing to notice here is in the UID F0 configuration, the 7-byte what you get with the activation command is same as the 7-byte what is stored in the block 0. Next I'm going to try the UID F1. The difference between this configuration and the earlier one is, in this configuration you can have a shortcut. However, using this ACR122U, you cannot try the shortcut, because the activation of this tag is completely within the firmware of ACR122, the device which is over here. Probably if you are using PN532 commands, you can try to explore that. And the big question here is, when do we need that? When do you want to use this type of shortcuts? So that's something which I'm not very sure yet. So I'm going to activate. So activate. So try again. Yeah. So when you activate, so this time we got a different UID, and still the screen shows the previous tag content. I'm going to authenticate, or the best thing is I would rather start from the beginning. So take this tag, place it again, activate. You got a different 7-byte UID, and there's nothing different here, so I'm just going to show this quickly. Read, and these 7 bytes, and remember in this UID F1 configuration you still get the 7-byte UID, and all the 7 bytes are stored in the block 0. So next I'm going to show the UID F2. Now this is a very interesting configuration, which probably this gives some kind of a security for the MIFARE Classic type of tags. And you know that in my previous video I mentioned that this UID F2 is about a random ID. So the MIFARE Classic tag has got internally, it has got a microchip. It has got a random generator. So every time you activate, you will get a different random ID. And the random ID, as you can see here, I'm going to activate. So this is the UID, and this UID starts with 08. So if you come across a UID that starts with 08, okay, it is always a random ID. Now I'm going to again, because the activation, everything is done within the ASR122 reader writer, you don't see anything much here. So I'm going to activate and I'm going to read. So you don't see anything difference here. So I'm loading the keys, the default factory keys I'm activating here. And the main thing to notice here is this is the original 7-byte UID that came with this tag. Now there is no relationship between these 7 bytes and what you get here. This is a purely generated by the random generator, probably component, which is part of the MIFARE Classic tag. Now I'm going to activate again. So clear, take it out. Just to remember, this is 8560. Let's place it again, activate. This time I got a different number. Looks like we can use this concept to generate a random numbers. And every time you activate, I'm going to authenticate and read the sector. You still, this will never change. So again, I'll activate once again. So keep an eye here. It has got different RAM number. So every time you activate, you get a different UID. Now, what are the plus points of this configuration? The one thing I like in this configuration is the UID. Okay, for example, okay, let's start here. I'll tell you what exactly I want to say here. So I'm going to activate this tag. Okay, so the activation gives me a number. It's a random ID. However, you cannot read the see, if you want to get the UID, the original UID of this tag, you have to read the content of the block 0, and you cannot read without the authentication. So you must know the value of the key A, which in the real card will not be a factory keys, will be something different, which so that way, so you can protect the UID from seeing, from general access. So if you activate, right, okay, so that is all about this configuration. So next I'm going to, this is not any different. This is, see, UID F3. It's just like a normal classic tag with the 4-byte UID. Now it is not, it's not just that MIFARE Classic tag. Keep in mind, this MIFARE Classic EV1 has a feature called the originality check, so which is a very a good feature for a developer to build a secure system using this MIFARE Classic EV1 tags. Now I'm going to activate this. We know that because this was configured for a UID F3, you get 4 bytes. However, let's try to see what is the content of the block 0. If you look at this, this is the original 7-byte UID that was set by the manufacturer, and there is no relationship between this and that, but this is fixed. This is not like a random ID. So even I'm going to activate this again. So try this again, activate. Now this will never change. However, the value of this 7-byte UID is something different from what is stored. Somehow I just cannot make out where this number is stored. Is it stored somewhere in this block, or it stored somewhere outside this memory where it is not accessible to the user, or is this derived from these 7 bytes? We just don't know. Probably we'll try to explore, once I come to know how this generated, I'll make one more video on that. In this document, MIFARE and handling of UID, if you go to the section 3.2.2, there is some information about how to derive a single size UID from a double size UID, and I just don't know whether is this algorithm used internally or something. We just have to now calculate this, and there's also a program in Annex B to generate the single size UID from this double side UID. Now this is my very old A0122 program, which uses a mix of PCSC commands and PN532 commands, and I'm sure the authentication in this version is done using the PN532 commands. So we have seen these videos in my we have seen this screen in my earlier videos, so I'm just going to briefly go through that. Now here, so I'm going to authenticate. You see that this is a 7 byte UID. However, if you want to authenticate using PN532, you have to send only the last 4 bytes. So the documentation clearly explains this, and I'm going to show you that soon. So let's if we click on authenticate, so this button does so many things here. It authenticates and also reads the content entire sector. If you look at these commands, now this is the PN532 command to authenticate. Now it is the command 4001. The command 40 is called as the data exchange command, and 01 is the tag logical number. I've got only one tag here, so that number is 1. 60 is authenticated using key A, followed by the block address 0, followed by the 6 bytes of key. I'm using the default factory key. And look at this, we have to send the UID. So I'm sending here the last 4 bytes of this 7 byte UID. I'm just going to show in the document where it says we just have to do this. So you can find this information in 2 documents. The one is the MIFARE Classic EV1 datasheet, as well as the UID handling data PDF as well. Now in the UID handling PDF, it's very clear. So I would like to go to this thing first. So look at this table 3.2.5. So if it's a MIFARE Classic EV1, if we have used the 4 byte NUID, this is, remember, this is our UID F3, you have to use the 4 bytes, the UID 0 to UID 3. This is all the 4 bytes which you get when you activate. And if the UID uses 7 byte UID, this is our UID F0, the very first configuration, you have to use the last 4 bytes of the second anti-collision sequence. So that's exactly what I did here. Now here I'm using the last 4 bytes. Remember, because it is 7 byte, the activation uses 2 anti-collision command, and these 4 bytes you get out of the second anti-collision command. Now if we are using the second configuration, remember it's a shortcut activation, we cannot check this with PN532 unless you do a bit of a low level programming. So here you have to use the 4 bytes you get with the first activation command. So here CT means 88, 88 followed by the 3 bytes of the UID. So you have to use 88 followed by this. In other words, you have to use whatever 4 bytes you get with the first anti-collision command. If it's a random ID, that is the configuration 3, you have to use the random ID for the activation. Okay, so it's interesting bit here. Okay, so random ID itself is used for activation. Okay, now if you go back to this the classic EV1 datasheet, and there is a mention about authentication, and it says for you have to read from here. For UID F0 you have to use a sequence 1, and that sequence 1 is use the last 4 bytes of the UID. That's exactly what we did now. If the card is personalized to UID F1, you can use either sequence 1 or sequence 2. So sequence 1 is same as this. Sequence 2, what it says is the first 4 bytes, which including the CT88. If it is set to the random ID, you're going to use a sequence 3, and the sequence 3 is whatever 4 bytes of random ID you get. If it is the UID F3, the fourth configuration, you still use a sequence 3, so you just have to use the 4 bytes. Okay, so it's mentioned in this and the other document. So I'm going to close this, try this time. Obviously no difference in UID F1 unless I get this shortcut thing working. So authenticate, we still use the last 4 bytes of authentication, so this is the same as before. I want to change that to, so this is the random ID. So I'm going to, so you got a random ID here, authenticate. So authentication successful, as you can see here, you have to send the random ID. So this, the last configuration, it's similar to a standard classic tag. So I'm going to connect. So here it's the same thing. You just have to pass whatever 4 bytes of tag you got. Okay, so now we have understood how the activation work. I think the next thing will be going to be very interesting for you. It is how do we create, how do you personalize the tags, and you are going to need more tags. So probably have 5 or 10 tags for testing. So this is the command that is mentioned in the MIFARE Classic EV1 documentation. This is called as a personalize UID usage command. The command is 40, and the next byte is the value of 00 for UID F0. I'm not very sure why this command is here. So because by default, when you buy this 7 byte UID tag, it's already set to this UID F0. And if you want to set it for UID F1, you have to use 40, and this is the random ID, and this is for the 4 byte UID. So before that, you just have to understand this as well. The execution of this command requires an authentication of sector 0. Now once this command has been issued and accepted by the PIC, the configuration automatically locked. So the way it works with ACR122 is a little bit different, so I'm going to show that soon. So what I have got here is, this is the ACR122 made easy software. So I'm going to use this ACR122 console. So I'm going to place a brand new EV1 tag, which is already in the first configuration. So these are the commands you have to run. So before that, we have to activate it. Click on activate, and this is the UID. The way this whole command works is different, as I mentioned before. You have to just see that the ACR122 flashes and gives a beep sound, and it also tries to reactivate. If you already have this one, as whenever you bring the tag, so when you bring the tag, you get a nice sound in your computer. So activate again. Now these are the 4 commands. You have to run them as a batch, otherwise it will not run. I will tell you why. The first two commands are for activation, and this is to load the keys and activate, and this one is to read the tag, so read the content of block 0, and this is the one that changes the configuration. And this command is called as a direct APDU. If you look at the A72 documentation, this is nothing but a PN532 command. So the D4 is a P1 532 command that tells about the direction of the command going from your PC to the PN532 chip. 42 is a command called in communication through. If you look at the PN532 user manual, you see that 42 command is used to send directly to whatever tag is in the field. 40 is what we saw in the documentation. This is called personalization command, and 20 we want to set that for the random ID. Now I'm going to send this command as a batch. You just have to have a look at this light and a flashing thing, and also a resetting sound. If you see the light has gone up, it has come back again. I heard a sound in my PC as well, and I somehow get this. I know that this 02 is an error. It's some kind of a timeout. So I'm not too much bothered because I know it works. Now if you go and activate, look at that. You started getting a ID here. So I'm not very sure why I got 2 it's supposed to be 08. So let's try to reactivate this again. Activate. So it's 08. I think you have to take it out of the field and bring it back. Now every time you activate from now on, you start getting the random IDs. So activate, look at that. So now we have configured or personalized this tag with the RID. Now next we are going to say how to do this with the next one is with UID F3, and you have to use the command 60. Let's give it a try. I can't use this, so probably I have to use this for experimenting my software. So I'm going to clear all. I'm going to bring one more new classic EV1 tag, and this time, since we agreed for the 4 byte, I'm going to set that for 60. Copy paste these 4 commands, but change this to 60, and you have to activate. This is showing the tag is set to 7 byte UID, and if I run this, you just have to see that the light has gone. Take some time, it's going to come back and activate again, and take it out of the field and bring it back and activate. You can see that you get a 4 byte UID, which is always fixed to this number. It will never change. So now we have set this tag for the configuration for. So you can still run all these commands. If you want to try doing again, let's give it a try now. Just what happens if I want to set it to something else? So set it back to random ID. In theory it shouldn't work, but give it a try. Now there's no response at all, so let's activate this, activate, and send this. So it did flash a little bit, but I didn't hear any sound. So I'm going to take it out and try again. Activate, look at that. So let's give it a try from the beginning. Console. Now, so that as you see here, you cannot change this to something different. We try to change this to RID, the configuration 3. We can't. Now this is frozen. The last one we are going to try is the UID F1 which is set to 40. So what I'm doing here, just destroying my tags. So activate, set this to 40, and if I send, now here there's one thing you have to notice. Okay, we did not hear any beep sound. Okay, however, so because here we are not changing the length of the UID. The UID still remains the same, 7 bytes, but only difference between the config 0 and this one is this configuration can be used to do a shortcut reading, which we saw in the CR in the earlier videos. Okay, probably now I'm going to try this. I'm going to see that whether it has done it. So I'm going to read again, activate, and read again. You can see that the block 0 has been read. I mentioned something about running this everything as a batch. So this is something to do with the ACR122U device. It automatically, once you authenticate, it automatically loses some kind of a connectivity. Okay, so for that you have to set this auto pull to off. So let's give it a try. So I'm going to use one more tag. So I'm going to try running this command. I'm not going to run this command within in the batch. So I'm going to run the first 3 command. So I'm going to follow this as a step by step. I'm going to authenticate and read the block 0. So you don't have to do the block 0 reading here. I just got the command here so that I know the authentication is successful. Now I'm going to take this out and now paste this the command to set to the random ID, and I'm going to send this command. Now see, nothing has happened. Okay, it is because of the way the ACR122 works. Now if you want to run this in our own time, you have to first make ACR122 to stop doing this auto pull. So if you click this, what I'm doing internally is sending a command to set the auto pull off. Now let's try to activate, or you can start from the beginning. Okay, if you go here, activate, and once is activation successful, I'm going to set the auto pull to off. Now I'm going to run. So you don't have to try these methods. The earlier methods are straightforward. You can just use it, run all the 4 commands. Now this is done. I'm going to take this out and run this the personalize command now. Send. Now because the activation is auto pulling is off, you don't see any flashing or any reactivation command. So the only way to test this is to bring the activation on, and I'm going to place this tag again. Look at that, you got the random ID. So I also spoiled this one more MIFARE Classic EV1 tag as well. Okay, now the only thing that's left now is to check that we are able to do the UID 2 configuration, but you need this CR95HF. I'm going to do right away. So I've connected my CR95HF board and running this same software. I'm going to connect and choose this MIFARE Ultralight. So this is the card we just personalized. I have scribbled in a UID F2 and a demo here. I'm going to choose this through ready to and click on activate. Now if you're, as you can see here, you still get 7 byte UID, and look at the sequence. You got REQA, and you got the first anti-collision, the selection, then directly reading the content of block 0 or address 0, and you got this 16 bytes of data. So this proves that our personalize command did work for the configuration number 2.